Welcome to AS Online. Myself Krishna Reddy, Faculty of Electrical Engineering branch. Subject is Power Systems. In today's class, let us discuss about economic aspects. Actually, what do you mean by economic aspects? So, if you observe the power system network, it consists of what? Power generation unit. Generation is at remote place. Whatever the power that has been generated is being transmitted by using transmission network. Whatever the power that has been transmitted is being distributed by using the distribution network. So we have generation network followed by transmission network and distribution network. So whatever the power that is generated is being transmitted, whatever the power that has been transmitted is being distributed. So the consumer will be connected to this distribution network. The consumers will be connected to the distribution network. So when the consumer will be satisfied, consumer satisfaction depends on what? So when the consumer will be satisfied as a consumer, when we will satisfy two aspects. One is in terms of quality. Quality of supply should be provided. Quality of supply should be provided. And cost per unit is to be minimum. Cost per unit is to be minimum. So how can we minimize the cost per unit given to the consumer? So as we are talking about economics, so how can we minimize the cost per unit? So the cost per unit given to the consumer can be minimized by minimizing the cost of generation. So if you can minimize the cost of generation, the cost per unit given to the consumer can be minimized. That's what the economic aspect says. Minimize the cost per unit of generation so that the cost per unit given to the consumer gets minimized and the consumer will be satisfied. Okay. So now let us see some basic definitions. So first one is connected load. So what do you mean by connected load? So connected load is defined from consumer side. This is from consumer side. So in a consumer premises, if you add the ratings of all the electrical equipments, that will give the connected load of that consumer. So it is the sum of the continuous ratings of all the equipments connected to the supply system. This is defined from the consumer side. Nothing but if you add the ratings of all the electrical equipments in the consumer premises, that will give the connected load of that consumer. Now let us see what do you mean by maximum demand. So if you observe, the variation of power drawn by the load with respect to time, so load is not constant, which is a continuously variable parameter. Maximum demand or maximum load is nothing but it is the highest amount of power that has been consumed by the consumer or delivered by the generator for the shorter interval of time. Okay, greatest demand of load on the power station during a given period is known as what? Maximum demand. So highest amount of power consumed by the consumer or delivered by the generator for a shorter interval of time is known as what? Maximum demand. Now let us see what do you mean by reserve capacity. So what is a reserve capacity? How do you calculate? It is a difference between what? Plant capacity and maximum demand. Reserve capacity is the difference between the plant capacity and maximum demand. So reserve capacity is equal to installed capacity minus maximum demand. So we can say that if reserve capacity is positive, then installed capacity is greater than maximum demand. Then the system is stable. If the reserve capacity is 0, then the system is critically stable. If the reserve capacity is negative, then the system is unstable. Okay, reserve capacity is positive, then the system is stable. 0, critically stable. Negative, it is unstable. Reserve capacity is the difference of plant capacity and maximum demand. Now let us see what do you mean by average load. Average load means what? Average of loads occurring on a power station in a given period is known as average load or average demand. If you take the average of loads over a given period. So how do you calculate the average load? Before going for calculation of average load, 1 unit is equal to what? 1 unit consumption is nothing but 1 kilowatt hour. 1 unit is equal to 1 kilowatt hour. So how do you calculate the average load? Average load or average demand is nothing but total number of units or total energy consumption. Total number of units generated or consumed, whatever it may be. Total number of units generated by total time over specified duration. Total time over specified duration. Okay. So average load is nothing but total number of units generated by total time over specified duration. Here, if you are calculating daily average load, take it as 24 hours. If you are calculating annual average load, 8760 hours. Okay. Annual, if you are calculating daily, you can also calculate monthly average load or annual average load like this. Okay. So now, once we know the average load, maximum load reserve capacity, all these terms, now let us go for the analysis of load factor and how it will influence the cost per unit. So here the load factor, generally the questions will be asked on this. Load factor is nothing but it is the ratio of average load by maximum demand. Okay, average load by maximum demand. So if we observe, load factor is nothing but is the ratio of average load to maximum demand. We know that the maximum demand on the station is greater than the average load. Okay, maximum demand will be greater than what? Average load. So as maximum demand is greater than average load, what we can say? Load factor will be load factor is less than 1 or less than 100%. Load factor is less than 1 or less than 100% we can say. Okay. So what is our observation? This may be the objective type question. Load factor will be less than 1 or greater than 1. And what do you mean by load factor? It is the ratio of what? Average load by maximum demand. Okay. So how this load factor will influence the cost per unit of generation? So for the cost per unit of generation to be minimum, the load factor should be high or low. So for cost per unit of generation, to be minimum, the load factor should be high. The load factor should be what? High or low? It should be high. So how higher load factor will influence the cost per unit of generation? So if the load factor is high, it shows that average load is nearer to what? Maximum demand. If load factor is high, average load is nearer to maximum demand. Then the fuel consumption will be reduced. So fuel cost is minimized. We can say running cost is reduced and the cost per unit will be minimized. So if the load factor is high, what we can say here? If the load factor is high, it shows that average load is near to maximum load. So if the load factor is high, what does it show? Average load is nearer to maximum load. If average load is nearer to maximum load, then amount of fuel required will be less. Required is less. So if the amount of fuel required is less, fuel cost will be less. Fuel cost gets minimized. So if the load factor is high, fuel cost will be less. If the fuel cost is less, then running cost, this fuel cost comes under what? Running cost. So running cost gets minimized. If the running cost get minimized, the cost per unit get minimized. So for the cost per unit of generation to be minimum, load factor should be high. Okay. So objective type question may be framed like this. For the cost per unit of generation to be minimum, what should be the load factor? Load factor should be high. So then it shows that average load is nearer to what? Maximum load. Then running cost gets minimized and the cost per unit will be less. Okay. So now let us go for the further analysis of diversity factor. What do you mean by diversity factor and how it will influence the cost per unit of generation? So if you observe diversity factor, it is a ratio of sum of individual maximum demands, sum of individual maximum demands. So diversity factor is a ratio of sum of individual maximum demands to the simultaneous maximum demand on station. Okay. Diversity factor is ratio of what? Sum of individual maximum demands to the simultaneous maximum demand on the station. Now the diversity factor value will be less than 1 or greater than 1. No doubt the sum of individual maximum demands will be more than the simultaneous maximum demand on the station. So the diversity factor is greater than 1. Very important objective type question. The diversity factor value will be greater than 1. Now the question may go like this. For the cost per unit of generation to be minimum, the diversity factor should be high or low. The diversity factor should be high. For cost per unit of generation to be minimum, the diversity factor should be high. The diversity factor should be high. For the cost per unit of generation to be minimum, the diversity factor value should be high. So what happens if the higher diversity factor indicates? What happens if the higher diversity factor indicates? If the diversity factor is high, then the simultaneous maximum demand on the station will be low. Okay. So what is if the diversity factor is high, what does it show? It shows that simultaneous maximum demand on the station is less. Okay. If the diversity factor is high, the simultaneous maximum demand on the station is less. If the simultaneous maximum demand on the station is less, then the installed capacity required will be less. If the installed capacity required is less, then cost of machinery gets reduced. That means fixed cost reduces. If the diversity factor is high, fixed cost reduces. Okay, if the diversity factor is high, what does it show? Fixed cost reduces. Fixed cost reduces, then automatically the cost per unit gets reduced. So for cost per unit of generation to be minimum, the diversity factor should be high. If the diversity factor is high, it shows the simultaneous maximum demand on the station is less, then fixed costs get minimized and cost per unit get minimized. Both for the cost per unit of generation to be minimum, load factor should be high, but load factor is high, running cost is minimized. But if the diversity factor is high, fixed cost is minimized. These are the important points that we need to keep in mind. Now let us observe here. So what do you mean by coincidence factor? What does the coincidence factor indicate? Coincidence factor is nothing but reciprocal of diversity factor. Okay. So as diversity factor value is greater than 1, coincidence factor value will be, it is greater than 1, it will be less than 1. Okay. Now let us observe this plant capacity factor. What does the plant capacity factor indicate? It is nothing but a ratio of average demand to installed capacity. Okay. Plant capacity factor is the ratio of average load to installed capacity. Plant capacity factor is the ratio of average load to installed capacity. As installed capacity will be greater than the average load, what we can say, the plant capacity factor will be less than 1. PCF will be less than 1. Okay. So now let us observe this one. What do you mean by operation factor? Operation factor is nothing but ratio of what? Operation factor is the ratio of what? Service hours to total duration. Okay. Service hours to total duration. Total duration. Here, some time will be taken for maintenance. Unit will be taken under maintenance. Okay. Total duration will not be under operation. So service factor, it will be generally less than 1. Okay. Service factor will be less than 1. So what do you mean by load curve? What does the load curve shows? Load curve is nothing but it shows the variation of power drawn by the load with respect to time. Here load curve is not load is not constant. Load is a continuously variable parameter. Load is a continuously variable parameter. So the highest point on the load curve gives the maximum demand or maximum load. Maximum demand or maximum load. Highest point on the load curve gives the maximum demand or maximum load. Okay. So area under the load curve gives what? Total number of units generated. Area under the load curve gives total number of units generated. Area under load curve. Area under the load curve gives total number of units generated. Okay. Area under the load curve shows what? Total number of units generated. Highest point gives what? Maximum demand. So average load can be calculated. Average load is nothing but area under the load curve by total time. Total time in hours. Okay. If you draw for 24 hours, it will get the daily average load. Okay. Like that we can calculate. So we can get daily average load, monthly average load as well as yearly average, annual average load also. So once you know average load and maximum demand, we can calculate load factor from the load curve. We can get load factor. Load factor is nothing but what? It is the ratio of average load to maximum demand. Average load to maximum demand. We know already how to calculate the average load and maximum demand. That's what the load curve shows. Okay. So what do you mean by load duration curve then? Load duration curve shows what? It is similar to load curve, but this is obtained from the load curve. It shows the variation of power drawn by the load with respect to percentage of time. Here, in case of load duration curve, the loads will be arranged in the descending order. So suppose this amount of load is existing for 4 hours, 4 by 24 into 100. This is existing for 8 hours, 8 by 24 into 100. Here it shows load duration curve is obtained from what? Load curve itself, but here loads are arranged in the descending order. In load duration curve, loads are arranged in descending order. Okay, descending order. Loads are arranged in the descending order. So load duration curve shows what? The variation of power drawn by the load with respect to percentage of time. Loads are arranged in what order? Descending order. Now let us observe what do you mean by demand factor. Demand factor means what? Ratio of maximum demand to connected load. So demand factor shows what? Demand factor is the ratio of maximum demand to connected load. Which will be more? Connected load is greater than what? Maximum demand. Connected load will be greater than maximum demand. So demand factor will be less than 1 because connected load will be greater than what? Maximum demand. Demand factor is less than 1. Now let us observe some questions like this. This type of questions can be asked. What is the value of demand factor? Less than 1, greater than 1, equal to 1, none. So demand factor is nothing but maximum demand by connected load. Connected load will be greater than maximum load. So it will be less than 1. Now let us observe this question. Generating station has a connected load of 40 megawatt and maximum demand of 20 megawatt. Demand factor is nothing but maximum demand by connected load. What is the maximum demand here? 20. Connected load is how much? 40. Okay. 1 by 2, that is 0.5. Okay, here the connected demand factor is 0.5. This type of questions can be asked in the examination. Now let us observe here. The value of diversity factor is, so the diversity factor value will be more than 1 because it is a ratio of sum of individual maximum demands to simultaneous maximum demand on the station. It will be more than 1. So now let us observe here. A 100 megawatt plant has a maximum demand of 50 megawatt. What is the reserve capacity? So reserve capacity is nothing but difference of installed capacity and maximum demand on the station. Installed capacity is 100, maximum demand is 50, this is 50 megawatt. So reserve capacity is 50 megawatt. Reserve capacity is how much? 50 megawatt. Okay. So these are some of the points that we can discuss from economic aspects. Okay. I thank you all. I wish you all the best.
Main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESE 2020 and ESE 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series